Hello, my name is John Ford, and welcome to my Proxmox Automated Environment Provisioning course series. In this video, we're going to talk about the best practices for creating virtual machine templates within Proxmox, and I'm going to talk about how to actually take that network that you have built yourself and convert it to a template that can later be cloned. There are a couple prerequisites for this video. First of all, you should have been following along in the series where we already went ahead, installed our pfSense firewall and got that set up, and additionally created a management machine. The second requirement is that you already went ahead and created the network that you want to provide your users with. So if you haven't done that yet, go ahead and do that now. Go ahead and set up the network the way you like it, and then come back here where I'll talk about how to take that network that you set up and then convert it to a set of templates that can then be provisioned for each user that is using your service. Now I'm going to assume that you've already set up one instance of the environment that you would like to provide your users or your students with. But I'm going to assume that you have not yet converted those virtual machines in that environment to virtual machine templates. In my case, my environment that I will provide students with will consist of the machines with IDs 200 to 203. 200, 201, and 202 I've already gone ahead and prepared so that they can be converted to templates. However, 203 I've left fresh so I can show you the process I would take when converting this virtual machine to a virtual machine template that can later be cloned. When creating virtual machine templates, not just in Proxmox but in any hypervisor, there are some best practices that you should take on the OS itself before you convert it to a template. This is because there are certain aspects that each machine has that are unique to that machine, and simply cloning a machine will not make those aspects unique. Now, I'm not going to talk about this in depth because there are plenty of other guides out there online. For Windows, I would recommend using the sysprep utility to prepare your virtual machines. However, for Linux, I'm going to follow the steps that are illustrated both in the Proxmox official documentation and explained in a YouTube video that I will link in this description. However, I will go through those steps now just to show you everything I do all in one place. I would like to briefly mention that depending on your network setup, these steps might not be necessary. For example, if each of your users or students will have a completely isolated environment, then you don't have to go through this process and you can simply convert the virtual machines straight to templates like you will see later in this video. However, if you plan on having any shared networks between different users or different students, or if you would like to have a management machine that connects to each of the students' internal networks and manages the machines from there, then it's probably a good idea to follow these steps to clean up these virtual machines so that they can then be templated. And so then each copy of the virtual machine that the student receives will be fully unique. And so there will be no networking issues when you have duplicate machines on the same network. All right. The first thing I'm going to do is I'm going to install the qemu-guest-agent, and I'm also going to enable QEMU on this virtual machine in Proxmox so that Proxmox can better interface with the virtual machine itself. In order to do that, I am running a Debian Linux machine, and so I will use the apt package manager. I will do sudo apt install qemu-guest-agent. Of course, I will enter the sudo password for the user, And you'll notice that guest-agent is already installed and the newest version. The next thing I'm going to do is enable it in Proxmox itself by going to Options. And now we're going to go to qemu-guest-agent, click Edit, and I'm going to enable it by clicking Use qemu-guest-agent and click OK. This change will not take effect immediately because I have the virtual machine running, but if I were to restart it, you'll notice that this change will take effect. I'll do that really quickly just to demonstrate this. I have gone ahead and rebooted my virtual machine, and you can now see that where it says qemu-guest-agent, it is now marked as enabled. Additionally, if I go to the summary page, I now see the IP address that has been assigned to this virtual machine that is displayed here. The next thing I'll do is I'll install Cloud-init. Cloud-init will automatically set up this virtual machine when new clones are created and configure everything that needs to be configured for the machine to be fully functional. I'll do this by saying sudo apt install Cloud-init. And I'll say yes. Once Cloud-init is installed, I will enable it so that it starts up automatically on the next VM boot by saying sudo systemctl enable Cloud-init. From there, each machine should have unique SSH host keys. This does not make a difference if you don't plan on having an SSH server installed. However, in this case I do. I'm just going to go to etc SSH. And as you can see, we have a lot of files in here named SSH host. These are all the different host keys available for this machine. I will go ahead and remove them all by just saying rm SSH host. And then I'll put this star wildcard. And I'll just say yes. Of course, I forgot to do this with sudo privileges, but because the user I'm using doesn't have access to this directory, I'll have to run that command and prefix it with sudo. All right, now if I list out the files, you'll notice that those SSH host keys that were in this directory before are all gone. The next thing I'm going to do is I'm going to empty the machine ID file, which contains an ID that is unique to each Linux machine. I'll do that by saying truncate size0-s0/etc/machine ID. Again, I have to run it with sudo privileges, or root privileges I should say, because the user I'm currently using does not have the privileges to edit this machine ID file. I'm also going to check for the existence of other copies of this machine ID file, and if they exist, I will have to remove them. I'll do that with find/-name machine ID, and I'll redirect any errors to dev null. In addition, I'll prefix this with sudo so that I have permissions to search in every directory. You'll notice I do have another file called machine ID that's in var lib dbus machine ID. If I go ahead and print the contents of that, you'll notice it does still contain that machine ID. A very easy way I can fix this is by removing this file and then setting it to simply be a link to this etc machine ID file. Once this virtual machine is restarted, for example, if a clone is created and a clone is started, Cloud-init will automatically go ahead, it'll edit the etc machine ID file and assign it a new randomly generated machine ID. Anyway, I'll use sudo rm var lib dbus machine ID to remove that file, and then I'll create a link with ln-s. The source for that link is etc machine ID, and I want to create it in var lib dbus machine ID. And now, if I print out the contents of that machine ID file again, it should be empty. And if I just list it, or var lib dbus machine ID, you'll notice that it is indeed a link that points to the etc machine ID file. With these changes, there's one last thing I'm going to do. I'll say sudo apt clean and sudo apt autoremove. This will remove the apt package cache and remove any packages that are left over that are unneeded. Once that has completed, we are fully ready to convert this virtual machine to a virtual machine template. Depending on how you convert it to a template, this next step may be unnecessary, but I'm just going to go ahead and shut down this machine. One more thing I'd like to briefly mention is that you can assign IP addresses to cloned machines using Cloud-init. However, this will only work on Linux because Windows does not support Cloud-init. If you do plan to do this, make sure that you have installed Cloud-init in your virtual machine, just like I showed you before with sudo apt install Cloud-init. In addition, we'll have to create a new Cloud-init drive. In order to do that, I'm going to go to Hardware, Add, Cloud-init drive. From there, I'll select a storage location, local LVM is fine, and click Add. The new Cloud-init drive will appear here. Once this is created, if I click on Cloud-init, you'll see I have all sorts of settings that I can configure. For example, if I wanted to create a default user with a default password, I could do so here. However, where this will really come in handy later is if we want to assign static IP addresses, that can be done using Cloud-init. In fact, the scripts, the Proxmox and pfSense remote management scripts, and the web interface that we will be using has built-in integration for assigning IP addresses using Cloud-init. Of course, we could do that manually right here by clicking on the ipconfig section, clicking Edit, and assigning a static IP address right there. In case you are using Windows instead of Linux, now I will show you the best practices for creating a Windows virtual machine template. First of all, we're going to need to install the necessary Virtio drivers on this Windows machine. But in order to install those, you'll have to grab the CD image from the official Proxmox documentation. You can simply search up Proxmox Virtio drivers on Google, and you should be taken to this page, although I will also leave a link to it in the description of this video. If you scroll down to the installation section and see using the ISO, you can grab either the latest stable version or the most recent version of the ISO. You can download this ISO to your Proxmox instance the same way as we have downloaded ISOs in the past. Simply right-click and click Copy Link Address. From there, back in Proxmox, if you click on the server to which you'd like to download the ISO, or click on the disk that contains the ISO images, in my case this is local, and click ISO images, then you can select Download from URL. You can paste that URL in here, click Core URL, and press Download. Once you have completed these steps, you should have downloaded the Virtio Windows drivers ISO. Going back to the virtual machine and going to the Hardware tab, if you don't already, add a CD or DVD drive to this virtual machine so that you can then open that disk ISO image. If you need to do this, you can always click Add and click CD/DVD drive. From installation, I already have the CD/DVD drive here, and I did not remove it. So I'm simply going to edit this existing CD/DVD drive and switch my ISO image to virtio-win.iso that I just downloaded, and click OK. Going back to the virtual machine by pressing console, you can see that it has detected that a new device has been added. If it wasn't, I could click on the File Explorer, click on this PC, and open the disk from here. Now, if you're using the latest version of Windows, like I am, in this case it's Windows 11, and you're using the latest version of the virtio-win ISO that you downloaded from the Proxmox documentation, you can simply run the corresponding installer file that matches your architecture. For example, I am currently using the 64-bit version of Windows, so I will run the x64 installer. Running this installer, I'll click Next, accept the license agreement, Next again. I'll click Next again, accepting the defaults, and click Install. This may prompt me to provide administrative privileges. I will simply click Yes. Then once the installation is completed, I can go ahead and click Finish. Now all the required Windows drivers have been installed in Windows so that it runs smoothly and efficiently within Proxmox. In addition, if I would like to install the qemu-guest-agent, I can do that by navigating to the guest-agent directory that is also within this CD/DVD drive, and clicking on the one that corresponds to my Windows architecture. In this case, again, I'm running 64-bit, so I will select the x86_64 installer and click Yes. This should go ahead and install the qemu-guest-agent for Windows. Just like with the previous example I was showing you where I was using a Linux virtual machine, you can enable that qemu-agent in Proxmox by going to Options and going to qemu-agent, clicking Edit, and switching it to Enabled. In my case, during installation, I had already checked the box that enables the qemu-guest-agent, so it is already enabled here, and I don't have to do that. Once these changes have been made and I have successfully installed the virtio drivers for Windows, as well as installed qemu, I can go ahead and reboot my Windows machine. After rebooting this Windows machine, I will show you how to then use the sysprep utility in order to prepare it for being converted to a template. Once Windows has rebooted, I have gone ahead and signed back in. Now, there are multiple ways to run the sysprep utility. One such way is using the Run dialog in Windows. So I will simply type in Run and click on Run. From here, I'll type in sysprep, or SYSPREP, and click Enter. This will bring me to the File Explorer where I see sysprep here. I will double click on sysprep. From here, I will select the Enter System Out-of-Box Experience, and most importantly, I will click this Generalize option. This will remove any settings that are specific to this instance of Windows, so that when it is then cloned and rebooted, all these settings will be regenerated, effectively creating a new virtual machine that is completely unique. From here, for shutdown options, I will simply switch this to shutdown and click OK. From here, Windows will make sure that it is generalized, removing any settings that are specific to this instance. Then it will shut down, and I will be able to convert it to a template. When a user then tries to create a clone of this Windows machine and starts it again, it will provide them with an out-of-box experience where they will be asked to, among other things, set the administrator password and some basic settings before they can then log into their Windows clone. Once all this is completed and we are fully ready to convert our virtual machine to a virtual machine template, there are two ways of doing it. The way that's already built into Proxmox is simply right-clicking on the stopped virtual machine and clicking Convert to Template. However, let's say you have a very complex network and you have a lot of virtual machines that you want to convert to templates, and maybe some of them are running, some of them aren't running, and you want to quickly convert all of them to templates. This is where the template script that I created will come in handy. If I go back to my manager machine, where I have already gone ahead and I have installed the Proxmox and pfSense remote management scripts, I can simply use the template script here to convert a set of virtual machines to virtual machine templates. If I type in template and -h, it'll show the help screen that'll explain how to use this script. The script is pretty simple to use. All you have to do is say template and say the range of virtual machine IDs that you'd like to template. In my case, it's 200 to 203. In my case, 200 to 202 have already been templated, but that's fine. This template script will automatically check for that and ignore machines that are already templates. So if I do 200 to 203, I should convert this last virtual machine to a virtual machine template. The next thing I should mention is, in most configurations, you will be assigning a separate network interface for each environment that you create. This is if you want each user or each student to have their own unique network environment, right? You will dynamically generate those on the fly. This means that any existing, if I go back to the hardware for this virtual machine, any existing network devices are not necessary because a new network device will be generated on the fly. Now, some cases where it might be useful to keep this network device is if you want all cloned or all cloned environments to be on the same network. For example, if I wanted this example machine for the first user and the second user to both be on the same network, then I'm going to keep this network device here. However, if I want each user's network to be fully isolated, for example, I want user 1 to have their own environment, user 2 to have their own environment, and I want those to be fully isolated, I'm not going to have any network devices here because that new network device will automatically be created and added to the virtual machine when it is cloned. So if that is the case, and you would like each clone of this virtual machine to have its own network interface, right, that's dynamically created, then you also have to get rid of this network device that's here. Now you could do this manually, but again, just to showcase this, in the template script, there's a -r option that says remove network, and this will remove all network devices from virtual machine templates. This just kind of cleans it up and makes it nice and easy, so then when you do end up cloning it, later for each user, the network device will automatically be added, and there will be no existing network devices on there. So I'm just going to add -r in order to do that. And if I press enter, you'll notice that the example machine here has been converted to a template. If I click on it and go to the hardware tab, you'll notice that network device has automatically been removed. In addition, if the example virtual machine were running, it would be shut down first prior to being converted to a template. I did not demonstrate that because the shutdown process does take a little bit of time, and I wanted to show you how quickly this would run if the virtual machine has already been shut down. And that's all there is to it. Once you have created your environment and you've converted each of the virtual machines to virtual machine templates, you're all set to start cloning that environment.